let me introduce you to the sensor hub and to the hardware kind of side of things. I would like to start with an evolution of our prototypes. And those of you who follow us on Instagram or Twitter might have seen this one. This is the very first prototype we had. It is based on an Arduino microcontroller. It already had GPS geolocation, an accelerometer, and wireless transmission using the Sigfox network. So for this one, we came up with a very neat case design, I think, because this tube design fits a regular bottle cage. So you can put it on any bike. And this sensor design actually went to Paris with Peter. We live streamed this on our homepage. You might have followed this. So then we moved on because the first version didn't have air quality monitoring, and we had to duct tape the air quality sensor to the bike, and it was not very nice. So in terms of for getting a measure of air quality, we decided for particulate matter. This particular sensor measures PM 2.5 and 10 micrometer particles in the air. But yeah, this design was forcing us, or the size of the particulate matter sensor was forcing us to choose a bigger case design. We also included SD card logging because we realized we're getting tons of data. And what we then came up with is a very low-cost solution, but a very pragmatic one. We used the standard pipette tip boxes we had in the lab. The advantage is they have a transparent lid, so we could see all the status LEDs. We drilled holes for the SD card slot, for an air tube inlet, for the GPS antenna, and there were a lot of cables in there. It looks quite nice. It even went punting with us. And I think a handful of sensors are actually in distribution right now with this case design. But this is not where the journey ends. Our vision was to do a truly modular design of the sensor hub. So we decided to do our own printed circuit board, a PCB, that's modular. So even kids or the citizens themselves can build it. Just buy all the components or get a kit from us, stick it on there, flash the code, and there you go. So now I would like to guide you through the components we have. First of all, we have the heart of the whole system, which is an STM32 microcontroller. It's commonly called Black Pill. We chose it because it's very low cost. It only costs less than £2. It has a large number of communication pins and a lot of memory, 128 kilobits, so it could fit our code. The next bit is the GPS module. We chose the Neo 6M module. It features a very short cold start time, which we need. As you start cycling, you want to have GPS right away. It has a very robust antenna that doesn't interfere with our electronics because we have everything very close by and a lot of cables in there, as you can see. So there's low interference. The next bit is the accelerometer. It also features a gyroscope, so that allows us to measure the road quality and bumpy roads. We get spikes in the accelerometer data. The next thing is the particulate matter sensor, which is mounted below this PCB. We actually oriented the PCB side towards this particulate matter sensor. So it's basically a very flat and square thing now. Then we have the SD card still, which locks everything. It makes it very bulletproof. And a key feature is the LoRa transmission. LoRa stands for Low Power Long Range Radio. It has about a 10-kilometer range. It's a very novel technology because now we tend to connect everything via IoT wireless. So rather than Bluetooth or Wi-Fi or SIM cards, GSM network, we don't need a subscription here. We have a very long range and it works right away. So of course we have to power the device. So we use a lithium polymer battery for that, 1200 milliampere hours, 3.7 volts. Our components use different voltages, so most of them run on a very low power basis. So for example, the MCU, the accelerometer, and the wireless transmission, they all run on 3.3 volts, so we need to step down this 3.7 volts. But also, there's a more power-hungry component in there, which is the particulate matter sensor, so we need to step up to 5 volts as well, just to mention this. And a feature that I'm a bit proud of is the LED button, because we had many problems in Paris, for example, with this black tube, that you had to open the whole device before you could see what's going on. Is it on? Is it logging? Is the GPS actually catching reception? And this can act as a status LED as well. It can blink. We can do many things with it. It all comes together to this case vision we have. We had a couple of requirements to the case. It should be waterproof, because as you start cycling, weather conditions might change. But it also needs some air ventilation. This is hard to combine, but with the tube, we managed to find a way that kind of works. We also need a fixed orientation. It needs to be perpendicular to motion, because we don't want the airstream from the cycle wind to go right into the particulate matter sensor, so it needs to face the road. The tube faces the road for overtaking cars to suck in the particulate matter. Also, the sensor tends to aggregate over time the particles in there. So the data sheet says you should have it horizontally. So we decided to mount it under the seat post, for example, where it's always horizontally. Also, it should be detachable, because you might want to take your sensor off the bike inside to charge the battery. And it needs to be very universal. So every bike is different, and we want to fit it on every bike. And one last thing, many people ask us, how will the sensor case look like? Will it look cool? And yeah, it should be good looking. So this is what we came up with in the end. It's a wooden case. We laser cut it. We even have a transparent lid now, and the button. I hope it works. I might hand this around. You can attach it to your bike with these cable ties. We can try that after the presentation.